Alright guys, welcome back. Today we're going to talk about volume of solids with uniform cross-section. So yesterday we talked about the volume unit. Today we're going to start talking about how we find the volume of solids with different shapes. Today we're going to talk about a certain category called solids with uniform cross-section. Right, so what this is about is, if you look at these four examples over here. For example, the first shape, I'm going to cut it this way. Okay, so I'm going to cut it like horizontally, like I'm cutting a cake into half. And the second shape I'm going to cut in this way. Okay, so I'm cutting it sideways. Basically, I'm slicing the triangle into many different triangles. Okay, and then the third one I'm going to slice in this way. Okay, I'm going to cut in this way. And the last one I'm going to cut in this way. Okay, kind of the same as I'm chucking the blocks. So if I do that, what you're going to realize is, for each case, for example, the first case, what you're going to see is long rectangle being chopped. This is what we call a cross-section. Okay, so each time when you cut it off, for example, if you cut a star fruit, you're going to see a star. Right, so that's exactly what we're talking about in this case. And for the second one, if you have a triangle, right, you slice it that way, and for each time, no matter how you slice it, okay, as long as you're slicing the same way, you're always going to see a triangle cross-section in this case. Right, next one, you're going to be able to see a regular hexagon. Right, last one, you're going to see a circle, right, like this. So what does that mean is, it doesn't really matter where you cut it, right? You can cut it right in the middle, or you can cut it here, or you can cut it here, for example. Right, but no matter how you cut it, as long as you're cutting the same direction, you're always going to get the same cross-section on the side. And same here for triangles, and same here for the hexagon, and same here for the circles. Okay, so no matter how you cut it, as long as you cut it in the same direction, we're always going to be able to see the same cross-section, which is what's being drawn over here. So for these kind of shapes, we get that very special name called solids with uniform cross-section. Okay, SUCS. And for these shapes, their volume is quite easy to find out. So let's take a look at the next page. Okay, so in general, no matter what we look like, as long as we are the solids with uniform cross-section, I can give you one example over here, one crazier example. Right, let's say my base looks like this. Okay, and I'm uniform, right? So that means I'm basically like a tube. Right, I don't change my shape throughout. I just keep piling up exactly the same shape. So that all the way onto the bottom, I'm having exactly the same shape as the top. Right, so this is my shape, for example. Right, so this is a very special shape, right, because my base looks kind of arbitrary. But then you see I can actually pile up exactly the same way from the top to the bottom. Right, so this shape is another example of solids with uniform cross-section. How do we find the volume for these kind of shape? In this case, our volume is basically just going to be equal to the base area multiplied by the height. Okay, so what is your base area? Your base area is over here, right? So this is our base area. And then our height is just this part over here. Okay, we're going from the bottom all the way to the top. Okay, so for any solids with uniform cross-section, you'll always be able to find a height, right, that goes uniformly along the whole shape. And then you'll always be able to find a base area. All you need to do is just multiply the base area by height, which makes sense intuitively, because that basically means you're basically piling up the same bunch of paper with exactly the same shape. And that's what it means in this case. So base area multiplied by height. In terms of how do we find the base area, of course we're not going to be able to find the base area of this shape, because this one is quite arbitrary. But at least for shapes like triangles, rectangles, or even trapeziums or circles, we know how to find them. So let's take a look at a few examples. So number one, it's quite easy. Even using our intuition, we were able to solve that. Basically all we need to do is just the volume is equal to 7.5 times 6 times 4.5. But one thing that we can keep in mind is this is basically also the same as using the 7.5 times 6 to form the base area. And then you multiply this base area by the height. And then that's how you can find the volume as well. So this 7.5 times 6 is basically your base area. And then this 4.5 is basically your height. So you can think about it this way over here. Right? The answer will turn out to be, if you use your calculator, 202.5. And the units is centimeters cubed. And that's it for part A. Part B, we're looking at a hexagon. We don't really know how to find area of a hexagon, right? So, but we still need to find a base area. The good thing is they actually told us the base area is 30, okay? Because this is uniform cross-section, right? So the top base area will be exactly the same as the bottom base area. So it doesn't really matter which one they give you. In this case, they gave you the top one, so we're just going to use it. So in this case, our base area is actually equal to 30, okay? And we multiply by the height. Okay, what is my height? My height is this guy over here, which is 11. It's quite easy in this case. So what we're going to do is multiply them. Okay, we probably don't even need a calculator. In this case, the answer is 330 centimeters cubed. And that's it for this question. Alright, second question. Again, another example. But this time, just keep in mind that we need to round our answer to 3 sig figs. Okay, 3 sig figs is different to 3 decimal places. Right, 3 sig figs means I want to only keep 3 digits, basically. Okay, so we'll see. We'll see how we can do that. So let's go ahead and solve for these questions first. Part A. We have our base being the circle. Okay, so we first of all need to find the area of the circle. Notice that they only give us the diameter, so we need to find out the radius. The radius is equal to 2.5. So here's what we're going to do. We know that the volume is equal to the base area times the height. Now the base area is equal to pi r squared. Okay, r is equal to 2.5 Okay, so we're done with our base area. This whole thing over here will give us the base area. And we need to multiply it by 8, which is our h. So we punch everything into our calculator. The answer will be approximately 157 point something. But just because we're looking for 3 sig figs, okay, that means I want to keep 3 digits only. No matter your decimal point or your hundredth or your tens, we just want 3 digits in this case. So 157, 3 digits, that means we're good. So we are done for this question. Okay, so that's part A. Part B, the base looks a little bit more complicated. Okay, if you imagine this as our base, then that means this is our height. Okay, our height is equal to 7. So we need to use base area times height in order to get the whole volume. But the base, let's try to figure it out. Right, so let's cut that into 2 pieces. Right, so if you cut like that way, they already tell you that this is 3. So that means this will be 5 then. Okay, they tell you that this part is exactly the same as this part, which means this is 8. Okay, so we got 8, and then we can also cut the shape, in the same way that this is equal to 5, and this is equal to 3. Okay, so that's how we split them. And we can first of all add up the blue part over here on the top. Alright, the blue part is, so let's write that down. So we have base. The base is equal to, first of all, the blue part. The blue part is the width 3, the length 5. The 5 came from here. Okay, so 5 times 3, that's 15. So we'll do that later. We want to add the whole thing with the bottom bigger block over here. So that's 5 times 8. Right, 5 times 8, which is 40. Okay, so we combine everything together. So we got 3 times 5, 15, plus 5 times 8, 14. When you add them together, that's 55. Right, so 55 means your base area being 55 centimeters square in this case. And we just need to find the volume. Right, the volume is just our base area multiplied by the height. Right, the height in this case is 7. Okay, so we plug things in. Our base is equal to 55. Right, our height is equal to 7. Right, 7. So 55 times 7, this is going to give us something quite exact. Right, the answer is 385. We don't need to do any rounding anymore because, first of all, this is an exact number, and second of all, it does actually have 3 digits. So that's exactly what we want as 3 significant figures. So we're done. So the answer is 385. And that's it for this question. Right, the last question of the day, this is a little bit challenging. We are having this horseshoes magnet shape right here. First of all, let's decide, how we can cut this thing over here. Right, so I want us to imagine that we have this horseshoe shape as the base. Okay, so basically this whole part over here, right, this strange looking shape over here is actually our base. Right, this is our base area. We want to find an area of this shape over here, which is a little bit hard to do. But after we finish doing that, it's very easy because all we need to do is just multiply by 2, which is our height in this case. So we want to do the green part times the height in blue, so that we have base times height, and then we will have our volume, right, which is what exactly they're looking for. So let's find out what the base is. Okay, the base is not quite easy to figure out because, first of all, we will break the base into 2 parts. Okay, one is with this, semicircle, hollow semicircle thingy over here, and then the second part will be the 2 legs, right, 2 longer legs of your horseshoe shape. Okay, what does that mean? That means I'm cutting the whole shape like this, right? I'm breaking them into 3 sections over here. So first of all, I'm going to start out with finding this little rainbow arc shape, I guess. Now, remember that this is 8, so the whole thing over here is 8. So that means if you only cut that into half, right, that means if you only talk about from here to here, from center to one of the edges, this is going to give us 4. If this is 4, that means if you go from here all the way to the top, right, which basically means our height, kind of this whole shape, this is also 4 as well, right? And if that's 4, that means this guy over here will be equal to 4. That means the leftover, which adds up to 9, has to be equal to 5 then. Right? That means your leg, right, both of your legs, have the height of 5 in this case. So that being done, that's the first step. Right, so let's step back a little bit and try to find out, what other numbers are. Right, now second of all, you get a 3 cm over here. So that means my diameter for the inner circle, inner semicircle, will be 3. That means if you measure from the center to the edge, in this case, which is half of it, this will be 1.5 then. Okay, if that's 1.5, that means this guy over here has a leftover, which is 2.5. Okay, that means this should also be 2.5 as well, right, if you use the same trick. Right? If that's 2.5, what's connected to it, which is the leg, right, both of the legs, they should both have the width 2.5 or the length 2.5. Right, so it looks like we figured out everything. We're just going to plug everything in and we're going to find the base area in total. Right, so now the first thing that we're going to think about this as is, we want to think about this shape, the first shape, this guy, as the bigger semicircle subtracted by the small semicircle. Right, so our big semicircle is pi r squared divided by 2. The other smaller semicircle is also big pi r squared divided by 2. But our r's are different. Right? The first r is 4. Okay, we have a bigger r, and that gives us the whole area of the semicircle. And second of all, we want to subtract this by the smaller one in yellow over here. Okay, so that's 1.5, pi r squared. In this case, our r is 1.5. So big r, pi big R squared subtracted by pi small r squared, and both of them divided by 2. Right, so that's going to give me the whole area of that rainbow shape. So we're done with that rainbow shape. The only thing that we need to deal with are the two legs over here. These are easy. All we need to do is just 5 times 2.5 and 5 times 2.5. So like that. And when we punch everything into calculator, we're going to get 46.59845. Since this is not the final answer, what we'll try to do is we'll try to leave as many decimal places behind as possible so that our answers could be more accurate. And we carry that with us. We will have volume equals to, right, this is a solid with uniform cross sections. So we will do the base area times the height, which should give us the final answer. Okay, so our base is 46.59845. And then we multiply that by the height, which is 2 in this case. So quite straightforward. We punch everything into calculator. Now we can try to round things up a little bit. Our answer will be approximately 93.2 centimeters cubed. And that's it for this question. And that's it for today. I'll see you guys in the next lesson. Peace.